You are welcome to Timidial tutorial, and this lesson of today we want to look at a very important aspect. And as we all know, this is just for preparation for the examination of Jupeb at Unilag. And here in Unilag, this is what we want to consider today in our physics. This is a physics question and a physics explanation. And I remain the same Timidial. Once again, welcome to Timidial tutorial. And in this tutorial for today, we want to consider one of the basic principles or aspects in physics, and that is alternating current. Now, when you talk about alternating current, you are talking about a current that changes sinusoidally, that changes periodically. And if you talk about a change that occurs sinusoidally, that means what are we talking about? In that case, when you are having a graph like this, a sine graph, this is how you have your sine graph. Now, a current that changes in a sinusoidal form, that means that change periodically, is one that we refer to as an alternating current. Now, in this case, you might have your current here being plotted against time. So this is what we refer to as alternating circuits. It's circuits that alternate sinusoidally, or that changes sinusoidally, or that changes periodically, and that is what is meant by alternating current. And just like what we have here as the basis of alternating current changes its direction periodically. That is what I've said here. It changes its direction periodically, unlike direct current that change on a on a plane surface. The change in direct current is not in the case when you are having a negative and a positive and a negative, as the case may be. In the case of a direct current, it is direct, it does not change sinusoidally, and in that case, an AC, that means alternating currents are produced by alternating voltage. That means when you have your appliances at home, all our appliances at home that are powered by the PACN or by electricity, these are the ones that we call alternating current. Now, when you have a device that you use battery is an example of a direct current. In the case of a battery, you are having a direct current connection. But when it is an appliances that we use at home, our television, our TV set, all these, our fridge, our video, all these, they are being powered by an alternating current. And in that case, when you check your appliances, you realize that you could see they will write the alternating current or alternating voltage in that appliances. And this alternating voltage is the one that generates or that produces what we refer to as alternating current. Now, in that case, alternating current and alternating voltage are represented as follow. Alternating current and alternating voltage are represented as follow. Now, for the alternating current, you can see I is equal to I0 sine 2 pi ft, or you can have it as I equals to I naught sine omega t. Now, the same thing happens to alternating voltage. You are having V equals to V naught sine 2 pi ft, or you are having V equals to V naught sine omega t. Now, we want to define or explain or give a detail of what these terms that you are having here, what they mean. Now, where your I, the I you are having here, is referred to as instantaneous current. And instantaneous current equals, that is measured in ampere. Then we have our peak current, that is our I naught, is peak or maximum current. Now, in this case, this is where you normally have your I naught. This is the peak. This is where you have your I naught, and that's the same thing where you have, even though if you are plotting V against T as well, you're having your V naught here. This is the peak value of the alternating current or alternating voltage. Now we have F, which is our frequency, as we know that, and it is measured in Hertz. We have T, which is the time, measured in seconds. We have the theta, that's omega t is taken as theta, and we call it phase angle of current or voltage. Phase angle of current or voltage. Then we have the V, which is instantaneous voltage, measured in volts. And we have the the V naught, which is the peak or maximum voltage. Now we have the peak and the root mean square value. When you talk about the peak under an alternating current, what do you mean by the peak? Just like what we discussed the other time, in your alternating current, when you have your graph, now in this case we are talking about a sinusoidal graph, and in this case, this is the peak. This is the peak, and that is when you are plotting your current against your time, you are having here as your I naught. That is the peak for that current. And in this case, there is what we call the peak and the root mean square value. Just like the way we have it here, the peak value of an AC is the maximum value of the current recorded in an AC circuit. It is the maximum value that is recorded. The maximum value you can record in an alternating current circuit. This is a circuit, as you can see. This is a complete circle, as you can see. So in a complete circle, the maximum current you can record is what we refer to as the peak. This is what we refer to as the peak or the maximum. And we have the root mean square value. What does the root mean square value mean? The root mean square current is defined as steady or direct current which produces the same heating effect per second in a given resistor. Now, in that case, this is a DC. Now, the root mean square value is the steady or direct current, which is DC, which produces the same heating effect per second in a given resistor. So that is what it refers to as the root mean square value of a current and also of a voltage. The same voltage effect, the same direct current effect that produce the same heating effect in an alternating current is what we refer to as the root mean square in that current or in that circuit. So in this case now we have the root mean square current, which is the IRMS, and is equal to the peak over the square root of 2. That means the peak value over square root of 2. And when you find the square root of 2, it's 1.141. The reciprocal of it will give us 0.7. That's why we have 0.71i. Now what do I mean by that? This is talking about the peak is 1 I naught over 1.414. 1.414 is the square root of 2. So when you find the reciprocal of the peak of 1.414, that means 1 over 1.414 will give us 0.7. And that's why we have it as 0.71 I naught. And that is why we have in this case. Now we have the same thing. Now the peak current, that is the I naught. You just cross multiply here. When you cross multiply here, what will you have? You have the peak current, so equals to square root of 2 multiplied by the IRMS. That means the root mean square. And like I said earlier on, root 2 is equals to 1.414 multiplied by the current of the root mean square. Now the same thing we have, similarly, the root mean square voltage is VRMX. It's the same thing as the peak over the square root of 2. And just like what we have above here, we have the same thing here. Now, we have the peak voltage also, which is the V naught, and it's equal to root 2 multiplied by VRMX. Now, all what this is explaining is talking about the peak value and the root mean square. That means, what is the relationship between the peak value and the root mean square in an alternating current? Because we are going to be employing all these methods and all these formula when solving our equation. Remember the one we started with, where we talked about the I instantaneous current is equals to I naught sine omega t, whereby our omega is equals to 2 pi f. So when you substitute that into this, you know what you are going to get. You have your I is equals to I naught sine 2 pi f t. We are going to make use of all these formula when we are solving our question. But the best thing is that you understand what this is meant for. If you are new to this channel, ensure that you subscribe to this channel. Here we have the next one, which is the reactance and the impedance. When you talk about reactance and impedance, these are the terms that we are going to come across or that we are going to make use of when you are talking about alternating current. So when you talk about reactance, what do you understand by reactance? And what are the things you need to know about reactance? The same thing with impedance. Now, as regards reactance, reactance is defined as the opposition offered to the passage of an AC by either the inductor or capacitor or both. The opposition that is offered to the passage of alternating current either by an inductor or by a capacitor is what we refer to as the reactance. Now, and it is normally denoted as X. For the capacitor, we call it SC, and for the inductor, we call it SL. Now, when the position is offered, by the capacitor, it is called capacitive reactance. And when it is offered by inductor, it is called inductive reactance. Just like what we have here. Now, reactance due to an inductor is called inductive reactance. Inductive reactance is represented as XL, while reactance due to the capacitor is called capacitive reactance, that is LC. Now, we are going to be making use of all these things and this symbol when we are doing our calculation. Now, another thing is what we refer to as impedance. Impedance is the overall opposition offered to the passage of an AC mixed circuit containing a resistor and one or both of an inductor and a capacitor. Now, the opposition that is offered, the overall opposition offered by the resistor and a capacitor and also an inductor is what we refer to as impedance. Now, it can be that the opposition is offered by a resistor and a capacitor. That means we are combining the two oppositions, as in the opposition offered by, overall opposition offered by these two devices is what we refer to as the impedance. Is the overall opposition offered to the passage of an AC mixed circuit containing, when you are having a mixed circuit that is containing a resistor and a capacitor, or a resistor and inductor, that is when you are not talking about the impedance. Now, but in the first case, the opposition offered by just a capacitor is what we call the reactance, and we call it capacitive reactance. The opposition offered based on inductor only is what we call inductive reactance. Now, when you're not having a resistor with capacitor, we have what we refer to as the impedance. When you combine the two together, we are going to look at all this with a diagram to simplify and to explain what is meant by a capacitor and inductor. In the case of impedance, we represent impedance with X, with Z. And both the impedance and the reactance are measured in ohms. We measure them in ohms. Just like what we have here, we measure them in ohms, and you can see the symbol there. Now, another thing we need to just understand very fast is what we refer to as the reactance. Reactance is equal to amplitude of voltage across inductor or capacitor over amplitude of current through the inductor or capacitor. Now, like what we said, we have the X, which is the reactance. We say is the amplitude. We remember what we talked about our amplitude. Amplitude is what? V naught over I naught. V naught over I naught. And from here we could see that what is our V naught? Our V naught is what we have explained under the peak and the root mean square. Now, the V naught, just like what we have explained, we know that X is equal to V naught over I naught. And our V naught is equal to the square root of 2 multiplied by V RMS. Now, the same thing divided by the square root of 2 multiplied by IRMS. That means the root mean square value. So you can as well refer to it that, square root of 2 we cancel square root of 2. That means our impedance, our reactance can also be V naught over I naught, and it's the same thing as VRMX over IRMX. Now, this is one of the relationships that we are going to consider when we are discussing or when we are solving our calculation. But the major thing is that get the understanding of what they are, and when you are to apply them in the question, you should be able to answer it correctly. And like I said, this is for Unilag students that are writing JAM, that are writing Jupeb exam. In your Jupeb exam, these are the things that you are going to come across. You are going to apply or make use of all this when you are doing all this in your Jupeb exam for Unilag students. And once again, so there are so many questions you are going to consider in that, and in the course of that, we are going to make use of all these formulas. Now, in this AC circuit containing only resistor, what do you mean by AC circuit containing only resistor, and what are the basic things you need to understand about an AC circuit containing only resistor? Just like what we have in the diagram, you can see this is an AC circuit that consists of only resistor, and this is an AC source. So we are having the V root mean square and the frequency of the V root mean square. Now this is the current, the voltage that moves across the resistor. Now, the same concept that we have in an Ohm's law is still applied to this. And from Ohm's law, we have established the fact that our V is equal to IR. And what is R? V is equals to IR, our R is equals to V over I, and also I is equals to V over R. Now, in an AC circuit, we have established the fact that V is equals to V naught sine omega t, and I is equals to I naught sine omega t. Now, in that case, once we have established this fact, this is our instantaneous voltage and instantaneous current. And we have seen from this formula that we have here that R is equals to V over I. So from there you can substitute the value of your V, which is V naught sine omega t over I naught sine omega t. Now from here you can see that sine omega t cancels sine omega t. So what we have, or what is left, is V naught over I naught. So from there we can establish the fact that our R is equals to V over I, and is same thing as V naught over I naught. V naught over I naught. Also, from our root mean square that we have defined, we realize that our root mean square value, which is I R mx, is equals to I naught over the square root of 2. And also the V root mean square is equals to V naught over the square root of 2. So from here we've established the fact that our I naught is equals to root 2 multiplied by I root mean square. And also from here we've established the fact that our V naught is equals to root 2 multiplied by V R mean square. So from there we can as well substitute this also into this our resistor, and in so doing, what are we going to get? We are going to establish the fact that this is also equals to R to be equals to our V root mean square over I root mean square. So when you are having an AC circuit that consists of only resistor, ensure you understand what this formula is all about, because we are going to make use of them when you are solving your question. And that is for an AC circuit that is containing only. Now this is an AC circuit containing only inductor. In an AC circuit containing only inductor, this is the circuit diagram that we have for it. And from Ohm's law, just like what we have established, we realize that V is equal to IR. And we are still applying the same thing for an inductor. Now, the voltage across, and in this case, the voltage across an inductor is given as V is equal to I multiplied by XL, whereby our XL is the inductive reactance. Now, from there you can establish the fact that our inductive reactance, which is SL, is equal to V over I. And we have established that in an AC circuit, this is the same thing as V naught over I naught, and the same thing as V root mean square over I root mean square, and it's equals to omega L. It's equals to omega L. That means, and what's our omega? Our omega is the same thing as 2 pi f. So therefore, the inductive reactance is equals to 2 pi fl. 2 pi fl. That is the formula for calculating the inductive reactance for an AC circuit that consists of inductor only. And from here, we can the same thing, or at the same time substitute back what the value is in this case into what we have established from this formula here. So we have established that the voltage across an inductor is the same thing as current multiplied by the inductive reactance. So in that case, when you substitute your value back, you are having your voltage equals to I multiplied by 2 pi fl. Then what is the inductor? Can we find out the inductor there? The inductor L is the same thing as V over 2 pi fi. 2 pi fi, or we can simply put that our L is the same thing as V all over 2 pi L is equals to omega I. So we can as well apply this while we are solving questions that pertain to an AC circuit containing inductor. When you are having an AC that contains only capacitor, we are still applying the same concept just as we have in the case of resistor and also in an inductor. In this case, you want to look at the capacitive reactance. And for an AC that contains an AC circuit containing only capacitor, we are having that from Ohm's law, the voltage across the capacitor, that is, which is C, is VC. As you can see, the voltage across this capacitor is VC, and VC is equal to current multiplied by the capacitive reactance. So when you're not talking about the capacitive reactance, in this case, what's our capacitive reactance? Capacitive reactance is same thing as our V, just like what we have there, V naught over I naught, and same thing as VR root mean square over current root mean square, and the same thing as 1 over omega C in this case, 1 over omega C. And remember that our omega C, as we have established, is equal to 2 pi f. So when you substitute that into that equation, you have our capacitive reactance to be equal to 1 over 2 pi fc. 1 over 2 pi fc. This is our capacitive reactance. Now, from here, we could establish the fact that we can get the capacitor, find the value of capacitor when you substitute this value back into what we have here. Now, when you do that, what are we going to get? We could see that the voltage across the capacitor, which is this, equals to the current multiplied by the capacitive reactance. And we have established that VC is equals to I times 1 over 2 pi fc. So what is our capacitor in this case? So when you do cross multiplication, when you cross multiply, what are we going to get in this case? We have established the fact that VC is equal to I divided by 2 pi fc. So what are we going to get? We want to get the capacitor out in this case. So when you cross multiply, what will you have in that case? You are having current to be equal to 2 pi fc multiplied by VC. And what's our C? The capacitor. Divide both sides by 2 pi fvc. So in that case, we are going to have that our capacitor is equal to I divided by 2 pi fvc. 2 pi fvc. And we can establish that fact that our C is equal to I divided by omega VC. Now, these are the relationships that you are going to come across when you are solving your question under this concept. In an AC circuit containing only resistor and capacitor, for an AC circuit that you are having only the resistor and capacitor, remember what we said, that we are going to discuss about the impedance. And when you are talking about the impedance here, we are talking about the impedance, which is Z, for CR. That means the capacitor and the resistor. And we have established the fact that it is same thing as V naught over I naught, same thing as VRMS root mean square over I root mean square. And the same thing when you're having your Z CR for capacitor and resistor, same thing as the square root of R square plus SC square. R square plus SC square. And from here we can see that our current, the current, which is I naught, the same thing as V over ZCR, and which is the same thing as V naught over the square root of R square plus the capacitive reactance square. So you have to take note of all these formula when you are doing your calculation. And in this case, the current leads the applied voltage by theta. When you are having a resistor and capacitor connected together, the current leads the voltage by angle theta. And in that case, we are having our tan theta will be equals to VC over V out. And what's our VC? That is ISC over I out. So in that case, our current goes there. So we can see that the tan theta is equals to SC over R. SC over R. Then the effective or the total voltage across the circuit, VC and VR, is given as V, and that is equals to the square root of VC squared plus VR squared. VC squared plus VR squared, as you can see. So these are the things that you need to take note or put into consideration when you are dealing with an AC circuit containing only resistor and capacitor. And once again, like I've said, this is for Jupeb class for Unilag students. Jupeb class for Unilag students. You are still coming to an aspect where you are going to solve many questions. But before solving the questions, if you want to be or join this or subscribe to this, as we are going to be having series of classes for Jupeb students, particularly for Unilag students, you can subscribe to this channel, and you are going to see that there is a class going on for now, and that is on Zoom. And in that class, you are going to see under the link here, you see the link to join the Zoom class, and also this ID meeting. That means the ID to join the meeting and the password. Also, if you have any challenges, you have the contact to call under the screen. You can quickly do that and ask when to join the class, because the class is already going, it's ongoing already. But I will advise that you join the class to be part of the class, so that if you have some other challenges in your physics, in your mathematics, even in chemistry, you can come to the Zoom class. And AC circuits containing only inductor and capacitor. As you can see, we have explained AC circuits containing resistor and capacitor, AC circuits containing resistor and inductor. Now we want to look at AC circuits that is containing inductor and capacitor. Now in an AC circuit that is containing only inductor and capacitor, as you can see, we call it an inductor is represented with L and capacitor with C. So we call it LC series circuit. Inductor capacitor series circuit. And in an inductor capacitor series circuit, we can see that the impedance, which is ZLC, is the same thing as the RMS voltage over RMS current, and that is the peak voltage over the peak current, as you can see it here. And this is just the same thing with what we have explained under an AC circuit that is containing both inductor and resistor and capacitor and resistor. Now for the impedance, you can see in this case you are seeing SL minus LC everything squared. That means the impedance for LC circuit. And you can see this square, we cancel this square root. That's why we are having it as SL minus LC, as you can have it here. Now current in LC circuit, just like we have it here, our current in LC circuit, that's I naught, is going to be V over ZLC. And what is our LC? Our LC is the same thing as what we have here. That is SL minus LC. That means inductive reactant and capacitive reactant. So that's why we can substitute that here, that I naught is equals to V over XL minus SC. So that is the current that is flowing through a circuit that is containing both inductor and capacitor. Now, in the LC circuit, the inductor voltage VL and the capacitor voltage VC are out of phase by 180 degrees, and they are out of phase by 180 degrees. That means the effective voltage in that case is going to be just like what we have it here, the square root of VL minus VC, and the square, just the same thing, this square will cancel the square root. So our V equals to VL minus VC. VL minus VC. Now, like we have said earlier on, this is majorly for Jupeb students for Unilag that are preparing for their Jupeb examination. Ensure you subscribe to this channel to get more information. In this case, we are having AC circuits containing resistor, inductor, and capacitor. AC circuits containing both resistor, inductor, and capacitor. as we can see, we are having, this is the connection of resistor, inductor and capacitor, and the impedance, which is the overall, that means the overall opposition to the passage of electric current, which is the impedance, is equals to what? Z, and that is the Vrms root mean squared over the current root mean squared, and it is taken as the V naught over, we have established all these facts. We have put them out before. So the impedance here is equals to the square root of R squared plus SL minus LC everything squared. That is when you are having your resistor, your inductor and capacitor. This is inductive reactance and capacitive reactance. So in the case of impedance, or a series connection that consists of both resistor, the inductor and capacitor, this is how you get the overall opposition, which is the impedance. Then we have the current in the R resistor, inductor and capacitor circuit. That means the I naught is equal to V naught over Z, just like what we have here. This is written as V naught over Z, and our Z, which is the impedance, is what we have determined from here. Then submitting that into this place, we get the same thing. Then the phase angle is given by tan theta, and tan theta is equal to VL minus VC over VR. So our VL is written as current times XL, and our VC is equal to current times XC, and our VR is equal to current times R. So you can see that from here, I is common here, and that's how you are having LX minus LC over IR. This R cancel out. So from there we have established this relationship. Then the effective voltage is given in this form. Now these are the formulas that you'll be coming across by the time we go into deep into the equation, and we are going to come in across all those connections for series connection of resistor, capacitor and inductor. This is what you have explained. I think the next thing we have to understand here is about the resonance, frequency as resonance, and that's what we are going to discuss. Now if you are new to this channel, as we have said earlier on, ensure you subscribe to this. And this is Temidayo tutorial, and we are having physics here, and this is majorly for Jupeb students at Unilag. So we are having series of online teaching using our Zoom link. If you want to be part of this Zoom link, the Zoom link or the Zoom ID meeting and the password is shown to you under the screen there. Just look at the Zoom and the time will be communicated to you. If you want to get more information, also the number is there for you to write and to call to WhatsApp to get more information about this tutorial. Remember what I said again, this is Temidayo tutorial, and you are getting more information as regards your physics, your chemistry and your mathematics. In this aspect, we are looking at resonance in an AC circuit. Resonance in an AC circuit. A resonance circuit is an RLC circuit through which maximum alternating current flows. Now, in a case where we are having the combination of the resistor, the capacitor, and the inductor. Now, the maximum current, a circuit whereby you are having the maximum current flow, that is when you are experiencing a resonance. And at resonance, you are having your inductive reactance and capacitive reactance to be equal. That's why we said that the frequency at which resonance occurs is also called resonance frequency. And that is the major thing we want to determine. So how will you determine the resonance frequency whereby you are having the maximum flow of current in the RLC circuit? Now, in that case, and it occurs when you are having your XL, that means the inductive reactant and the capacitive reactant. Also, when you are having the voltage as the inductive voltage and the capacitive voltage, in that case you are also having resonance. So from what you have established here, that you are having XL equals to SC. What's our XL? Our XL is equals to 2 pi FL, and our S is equals to 1 over 2 pi FC. So the frequency at which we are having the XL, the inductive reactance because the capacitive reactance, is what we refer to as resonance frequency. Then now we now determine that. So this is our F naught and F naught, resonance frequency. So for us to determine the value of resonance frequency here, we are making F the subject of the formula. And from here you can cross multiply. Once we cross multiply, we are going to have this in this format. This is going to be 2 times 2, that is 4 pi square f naught square L and C. So, and this equals to 1. So you need f naught in this equation. So for us to make f naught the solid of the formula, you divide both sides by 4 pi square LC. So in that case, you're having your f naught square to be equals to 1 over 4 pi square LC. So what is now your frequency? Your resonant frequency. Our resonant frequency f naught is now going to be the square root of 1 over 4 pi square LC. Now the square root of 1 here is equals to 1 over the square root of 4 is 2. The square root of pi square is 5. Then the square root of LC remains LC the way it is. So therefore, we have established the fact that the resonant frequency is equal to 1 over 2 pi square root of LC. So this is the resonant frequency that you need to determine when you are talking about resonance in an AC circuit. And the current at which you are experiencing that, which is I, is equal to V over R. This is current at frequency, at resonance. That means when you are having the maximum flow of current. And this is the frequency at which you are having the maximum flow of current in an RLC circuit. So with this, you have so many questions that you are going to solve under that. Just note that you need to understand what this concept is and try to look at the formula so that when you are applying them in solving your questions, you understand what it is. Once again, this is the Midario tutorial. If you want to get more information about this, ensure you subscribe and share this video. Now here we are going to consider the power in AC circuit. When you talk about power in an AC circuit, average power in an AC circuit is given as P is equal to IV cos theta. P equals to IV cos theta, or P is equal to I square R. Now why do we get this one? Now we believe that, or we all know that from Ohm's law, that our V is equal to IR. V equals to IR. So if we remove V here and we substitute IR for it, that means we are having P to be equal to IV cos theta. So if you remove your V, which is the same thing as V equals to IR, so you are having I multiplied by IR cos theta. So you can have it as I square R cos theta, or you can have it as I square R. Now that is how we get this other formula from. Now where our I here is the root mean square value of the current, and the V is the root mean square value of the voltage. Now the theta here is the phase angle. That means angle of lag or lead between the current and the voltage. And here we have cos theta. In this place is referred to as power factor. Our power factor is the cos theta, and is equal to the what? Resistive or resistance over impedance. Resistance over impedance. That is R over the impedance. And remember here that we are talking about an AC circuit, whereby you are having your resistor, your capacitor, and your inductor. So the power factor here is the resistance over the impedance. This is how you calculate your power factor. In the case of that means the cos theta, which is the power factor, we calculate it in this way. Now we are going to go into the calculation in details, and like I've said, ensure you watch this video to the end so that you enjoy the equations and how to solve the questions that we have explained. We have explained all the concepts under the AC circuit, but now the major thing is that how are we going to now apply those concepts, apply those formula, apply those ideas, apply those knowledge in solving our question. So we are going to look into more details, and once again I tell you, this is the Midario tutorial. Ensure you subscribe to this channel to get more information, to get more idea. And this tutorial or this concept is majorly for Unilag students. Here in Unilag, we are dealing with this aspect in Unilag for Jupeb students. If you are writing your Jupeb examination, this is an aspect that you need to understand. This is the aspect that we want to consider the question based on our AC circuits. We have explained the series from the beginning to the end. But now let's look at work example, likely possible questions that you can come across for your Unilag Jupeb students. So this is just to prepare us for the Jupeb examination. and these are the likely possible questions that is likely to come out for the Jupeb, particularly for Unilag students. Now the first thing here is that the current I in an AC circuit is given by the equation I is equal to sine theta sine 100 pi t, where t is the time in seconds. Deduce the following from the equation. Now, what are the things that you want to deduce from the equation? Frequency of the current, the peak value of the current, and the R mean square value of the current. Now, in this case, we have seen what we are given in the question. We are given that I is equals to 30 sine 100 pi t. Now this is what you are given, but from the standard sine equation, that means you are having your I. You want to compare this with the standard one, and that is I is equals to, just like the one we have in the previous case, is equals to I naught sine omega t, or is equals to I naught sine 2 pi f t. Now we can see now that because our omega here is equals to 2 pi f, so we can substitute 2 pi f in this case to get 2 pi ft. Now from here, let's now compare what we have in this case, particularly in the second equation or the second aspect of the equation. That means you want to compare that with what we are given. So we are given I to be equals to 30 sine 100 pi t, and from the standard we have it as I is equals to I naught sine 2 pi f t. So from here you can see, if you compare the two, the first thing is that you want to determine the frequency. So that means comparing by comparison, we are going to have that 100 pi t is equal to 2 pi f t. Divide both sides by pi t. This by pi t. So pi t cancel pi t. Pi t cancel pi t. So what is left that we want to consider in that case is the fact that you are having 100 is equals to 2f. So therefore, our f is going to be 100 divided by 2, and that is what? 50 hertz. 50 hertz. That is the value for our f. And also, we are going to see that the peak value, that is another thing you have to determine. If you want to determine the peak value in this case, how will you determine your peak value? Our peak value is I naught. And by comparison as well, we can see that we are having I to be equal to I naught sine 2 pi f t. And from the question, you have I to be equal to 30 sine 100 pi t. So in that case, our I naught is equal to 30 amperes. 30 amperes. That is the peak current. Then the last but not the least is to find the root mean square value, of the current. And from there, we have established our relationship from that place. And what do we discuss? Let's see it how we can solve it here. We want to determine the root mean square value in that case. Now, our root mean square value of the current is equals to I naught over root 2. I naught over root 2. So we have the I naught as 30 amps. So that gives us what? 30 over root 2. So when you find at this point now, you can rationalize this. That means this multiplied by root 2 and this multiplied by root 2. So 30 multiplied by root 2 will give us 30 root 2. Over root 2 times root 2 will give us 2. So 2 goes there 1, 2 goes there 15. So this one gives us 15 root 2 amp. You can leave it as 15 root 2. And if you want to go further, you can press your calculator to find the value of root 2. And I think root 2, we're having 15 multiplied by 1 for 1.41414. So that's what root 2 stands for. Root 2 is equals to 1.414, yes, multiplied by 15. So what will that give us? It gives us 21.21 amperes. So that is the value for the what? For the current. And that is how we solve that question. You can see, once you understand the basic principle, to solve the question is very easy. So this is basically what will be coming across here. If you want to be part of this class, once you enjoy more of that about this tutorial, we are going to join our Zoom class. And in the Zoom class, we are going to discuss everything. We make it more simple and more clear to you, even while you are doing it at your convenience, at your home. So ensure you subscribe to this channel to get information on how to join the Zoom class, and the Zoom link will be given to you. Once you send your message to us through WhatsApp, send a message to me through WhatsApp, then the Zoom ID and the Zoom password is displayed down the screen. You can just join the Zoom, and the time to do that will be communicated to you in the course of this class. We are still solving more questions on this. Remember what I said, this is the Temidayo tutorial, and here in Unilag, we are considering the solution and solving questions for Jupeb students. You are going to get more of this question. It's just simple. If it's simple, I'll make it more fun and more, you take it, you get it more cheap. If it's not difficult, it's something that you need to understand. Once you are going step by step, we have so many questions. So this is just number 1 out of it. Do me please to subscribe to this channel to get more information. So considering the second and the third question, still under the work example on AC circuits. Now we have to calculate the peak voltage of the main supply of our root mean square value, which is 222 volts. We want to calculate the peak voltage. Now when you talk about the peak voltage, we have discussed that we know that our Vrmx is equals to V0 over root 2. And in that case, how will you get the value of the peak, which is the V0? The V0 is equals to root 2 multiplied by the Vrmx, and that is root 2 multiplied by 220 volts. Our root 2 is equals to 1.414 times 220. So if you press the calculator on that, you are going to get the value of what 1.414 times 220, and that gives us 311.08 volts, or simply put 311 volts. So that is how we calculate the peak value for that. Then for the third question, you can see that the current through a resistor in an AC circuit is given as, the current I is given as 2 sine omega t. Determine the equivalent, the DC equivalent of the current. Now, the DC equivalent of the current is going to be the RMS value. That is what we want to determine. And from this equation that we have here, we know that from the general equation, I is equals to I naught sine omega t. In this case now, by comparison, we can see that our I naught is equals to 2. I naught is equals to 2. Then this is the value of the question we are asked to find. We know that our RMS is equals to I naught over root 2. So what's now our I naught? That is 2 over root 2 multiplied by root 2 multiplied by root 2. So you can see, this one is going to give us 2 root 2. You are having it here as 2 root 2 divided by 2. Root 2 times root 2. So this cancels this. So therefore, our I root mean square is equal to root 2 amp. Root 2 amp. So that's how we solve that. As you can see, we are going to make the question or the solution very fun and very easy for you to understand. Here, a Unilag for Jupeb students. Ensure you subscribe to this channel to get more of this info. The fourth example on this AC circuit, like we said. Now in an AC circuit, the peak value of the potential difference is 180 volts. What is the instantaneous potential difference when it has reached 1/8 of a circle? Now in this case, what are we given? We are given that the peak value of the voltage, that's V0, is 180 volts. 180 volts. Now what is the instantaneous potential difference? That's the V. Now from here we have established the fact that V is equals to V0 sine omega t. Omega t is our phase angle. And what other things were we given? We had what is the instantaneous potential difference when it has reached 1/8 of a circle? 1/8 of a circle. A circle is a complete 360 degree. So 1/8 of a circle is the same thing as 1/8 times 360 degree, and that will give us 45 degrees. 1/8 of 360 degree will give us 45 degrees. So we can see that from here our V is equals to V0. What's our V0? That is 180 sine 45. 180 sine 45. Then from here we can find the value of our sine 45 and multiply it with 180 to get our final answer. Sine 45, as you can see, sine 45, so this is 180 multiplied by 0.7071, and that gives us times 180 127.28 volts. 127.28 volts. You can see that this is very simple because this omega t is our phase angle and that is our 45 degree. So we just substitute that in as omega t, and the V0 is given already. That's the peak value. So we can see this is solutions to questions based on AC circuits. Ensure you join this classroom in Unilag, and you will see that it's majorly for Jupeb students and to prepare you for the excellent results in your Jupeb examination that is coming forth. So make sure you join this class and subscribe to this class. We are having series of classes now. It's ongoing for now, and it's on Zoom class. Just like you are in your various room, you can join the classroom. The link to join the classroom, the Zoom meeting to join the classroom, and the Zoom password is displayed down the screen here. Ensure you join the classroom to solve so many questions. If you have any challenges in your various home where you are, just join the class. And if you are unable to join the class, there is a number that is shown on the screen to you now. Just send a message through to the number, and from there we'll get back to you. Just send your message, send your name, and once you receive your name, then you type your name through WhatsApp. Once you do that, we are going to get in touch with you, and we're linking you up on how to we send the details to you on the Zoom link on how to get to the Zoom class. And with that, you are into the class, and we are going to give you a lot of information and everything that you need to understand as refers to the Jupeb in Unilag. So with us here, we are safe. With us here, we are giving you the best, and with that best, you are going to have your best results. And we wish you all the best.